Right, this is video 7.7. Today we're talking about scale drawings. Hopefully this is something that you are fairly familiar with through your history classes when you've looked at maps in geography. Often use scale drawings because clearly a map is not the size of the world or of a country or of a state or of a town. You have to take a scale of the actual thing to make your drawing of it. So that's what we're going to be looking at today and tomorrow. Okay, a couple of vocabulary terms. These are applicable for today and for tomorrow. A scale drawing is going to be a two-dimensional drawing that accurately represents an object, clearly. So the scale is going to be the ratio of the dimensions in the drawing to the dimensions in the object. So keep in mind, whenever we're doing this, then it's going to be the drawing will be your first number in the ratio, and your object is going to be the second one. So if it's a 1 to 12, like say, let me rewrite that. Let's say it's 1 inch is 12 feet. Then 1 inch in the drawing is 12 feet in the actual object. So this can be the way you can see it. They may have it as a 1 to 20. A lot of times they'll have it like that, 1 to 20. So that's 1 unit in the drawing is 20 units in the actual thing. Most of the time though, it's going to have a unit with it. So like 1 centimeter is 1 meter in real life. Or you can have it where you have an equal sign rather than a colon, where 1/4 inch in the drawing is equal to 1 foot. Remember the conversion factors, it's okay if you have it that way because that is a ratio and they are equal. So we can use proportions to find unknown scale or length. So if we know the different proportions, we can find out what the scale is. So for example, if we had a length of an object on a scale drawing is 5 centimeters and the actual length is 15 meters, then what's the scale? How much is 1 centimeter equal? So the way you're going to work that is you're going to set up a proportion where your scale length goes on top and your actual length goes on bottom. We're going to use the same rule for all of the problems that we're going to work. So scale goes on top, actual goes on the bottom. So our scale drawing is 5 centimeters, so that's going to go on top, and our 15 is going to go on bottom. Okay, we're going to put that equal to what our scale is here. So our 1 centimeter is going to go on top, and what we're missing is going to go on the bottom, right? So as long as our centimeters are the same, so if we wanted to put the meters on top, that's fine, but it's just easier to keep the same rule. So we're going to do scale and scale, actual and actual, right? We're going to do our cross multiplying, so we're going to do our 5x, 5 centimeters times our x, which is going to give us 5x. And we'll do our 15 meters times 1, which is 15. So when we divide by 5, our x is going to be equal to 3. That means that our scale is 1 centimeter is equal to 3 meters. So let's try this one. If we know the length of an object is on the drawing is 3.5 inches and the scale is 1 inch to 12 feet, then what's the actual length of the object? So once again, we're going to do our scale over actual. So our scale is 3.5. We want to know our actual, so that's where our x is going to go. Our scale is 1 inch, and our actual is 12 feet. So we're going to cross multiply. We have 3.5 times 12, which is 42. And then our x times 1 is just x. So we would say that the actual object is 42 feet. It's important to keep your units in there. They give you units on purpose. We need to put them in our answer. In science, when you are viewing things under a microscope, it makes them look bigger. So a microscope is going to give you an idea of how big something is, and then you can measure it under your microscope. Use your ratio of your microscope view to find out the actual length. So in this case, our microscope has 1,000 to 1 view. That means that you're going to see it 1,000 times bigger than it really is. If we see a paramecium and he appears to have a length of 39 millimeters. What is the actual length? So we can take our scale length on top, which our scale is going to be 1,000 to 1, and our scale length of the paramecium is 39. So what is the actual length, right? So we're going to cross product here. So that's 1,000 x equals 39. So we do 1,000 times x, 1 times 39. Going to divide by 1,000. That's going to give me x is equal to 0.039 millimeters. Doesn't give us any other units than these millimeters, so we're going to keep the same millimeters. Now you can also use a scale and a scale drawing to find actual heights of things. So if a wall in a scale drawing is 3 inches tall, how tall is the actual wall? Now it's a 1/4 inch scale. Now what that actually means is that that's in general saying that 1/4 of an inch is equal to 1 foot, is this 1/4 inch scale. If we said it was a 1/2 inch scale, then it would be 1/2 an inch is equal to 1 foot. So in a 1/4 inch scale, here is our conversion. There's our ratio right there. So if the scale is 3 inches, and we want to know how tall the actual wall is, if our scale is 1/4 of an inch here to 1, okay, I'm going to do my cross products. That's going to give me 1/4 x is equal to 3. To get this 1/4 away from my x here, I'm going to multiply by the reciprocal, which is 4 over 1. That makes those cancel. The 4 and the 4 become a 1. The 1 and the 1 are 1. That gives me a 1x. So I'm going to multiply this side also by 4 over 1. It's going to give me x equals 12. So in real life, the wall is 12 feet tall. So what happens if the wall was using a 1/2 inch scale? So remember, when you're doing that, your 1/2 inch is equal to 1 foot. Okay, so I can set up the same way. My scale drawing is 3 inches. I'm looking for the actual size. 1/2 inch is my scale. 1/2 inch to 1 foot. So I can do 1/2 x is equal to 3. Get rid of my half by multiplying by 2 over 1. That's going to be x is equal to 6 feet. Go ahead and click on the link, complete the homework, and we'll do more practice when we get to class.